Hello, this is John Hart, and we'll be going over the 6.2 worksheet where we have this table as our reference, and we're just moving variables around in the matrix as an exercise, following the hints along the way. Each row will have a categorical variable of the main area of interest, non-drinker versus drinker. And we want to compare, we are comparing age in non-drinker versus drinker, education in non-drinker versus drinker, and so on. Continuous variables have standard deviation after the average. So 28.2 years plus or minus 4.4 for both in both groups. So this standard deviation is the same, and that tells us how spread out the numbers are. Different down here, where this has a larger standard deviation than this. So BMI numbers are more spread out or more varied in non-drinkers. So back to this part. See if we have any help here, no help here. Here's our help in this row. So we have the drinker type here, and that's one categorical variable, not continuous. Continuous meaning there's lots of possibilities, especially when there's a decimal place. So we have two continuous variables, one there and one here for BMI. No standard deviation with these two variables. Percent of mothers with education, that sounds like continuous, lots of possibilities with those numbers. But then the last part, greater than 12 years. So how many had greater than 12 years? How many had 12 years or less? Those are categories. So two categorical variables. So back to this. Let's just start, since we have drinker type already there, let's just start here. So we'll want to have age in one row, education in the second row. We'll see if that help is already there, and it is. So back to this first row. We already have drinker type, and we'll start with age. Age here, and we already went over what kind of variable it is, continuous or categorical. And we see a t-test is required. T-test is required for continuous variables. Otherwise, if we have two categorical variables we're comparing, then it would be the chi-square test, which is listed, so not listed that I see, but chi-square or t-test, those are the two choices for the statistical test. And the corresponding question for age, was age different? That's what these two tests are assessing, whether there's a statistically significant difference between the two groups. Two groups, again, are non-drinker versus drinker. Was age different between the two groups? Would be the research question. You can type the answer right below it, or you can come down here and answer it. And the p-value, well, we get that up here. Age, okay. Anything less than 0.05 is said to be statistically significant, meaning it probably did not happen by chance, and there's a real difference from a statistical standpoint. The next row, see if we have any helps. So no helps here. We know we need drinker type, so drinker type. And that would be, there is a help here. So categorical, so that would go here, the drinker type. We need drinker type in each row. See if we have any helps here. Education, there's our help. And there it is, the second row up there. So our response is education. Does it have plus or minus behind it? No. So we know what data type that is. And was it different? Is it statistically significant? Yes. So question and answer can go there. P-value, just fill those in there. Age, they're all very small except for the BMI. Not statistically significant. So these are essentially the same, the averages. However, they vary different. Their variance is different. One is 4.6, so one is 4.3. So we look at standard deviation to see if the variance is the same between groups. And just go ahead and finish the third and fourth rows. And if you have questions, you can post them under general questions. And thank you for watching.